Hi, everyone. Welcome to our CESA World Engineering Day webinar, where we'll be celebrating engineering excellence. My name is Ashlyn Guinness. I'm the current KZN YPF Chair and Professional Engineering Technologist at JTN Consulting, and I will be your facilitator for today. Before we begin, we would like to thank our sponsors, Kufanikiwa and Zutari, our diamond sponsors, and all our gold and silver sponsors who make these events possible as part of our CESA YPF initiative. This initiative consists of young leaders and volunteers who are passionate about engineering industry and are interested in ensuring development, growth, and promotion of the profession, thus ensuring the sustainability and of engineering skill for the country. CESA YPF membership is available to all qualified professionals in the engineering and built environment younger than 36 years of age. CESA YPF is operated on a non-profit basis and relies on sponsorship from CESA member firms as well as other interested parties that seek to grow YPs and understand the importance of developing young professionals for the industry. CESA YPF objectives include promotion and creating an awareness of engineering and built environment careers, the consulting industry, and CESA. Retention of young professionals within the engineering industry, building capacity, knowledge amongst members of the YPF, sharing information and networking, providing a platform for engineering practitioners to support each other with professional registration. That being said, today we are celebrating World Engineering Day. World Engineering Day is a crucial date in the engineering calendar. Held on March 4th every year, the official UNESCO International Day is a springboard for 12 months of shared ideas and inspiration in celebration of engineering and the vital role it plays across the globe. World Engineering Day has not only brought engineering communities together, but also promoted a deeper understanding of the industry amongst politicians, decision makers, business, educators, and the general public, shedding light on all too often unseen heroes of the modern process. In the spirit of World Engineering Day, we have selected one of our winners of our 2025 CESA Aon Awards to present on the winning mega project. WSP and team together will be presenting one of the most significant engineering infrastructure initiatives currently underway in South Africa. Eskom's operated and maintained distribution grid battery energy storage solutions, BESS project. Appointed in October 2021 as technical advisor for phase 1 of the 800 megawatt program, WSP has played a comprehensive role across 8 sites in the Western, Eastern, and Northern Cape, as well as KwaZulu Natal. Despite the complexity of running EPC packages concurrently across diverse locations, contractors, and environmental conditions, the team successfully guided packages through awards and negotiation. This 7.5 billion program not only strengthens grid stability and reduces load shedding through energy support and ancillary services, but also delivers meaningful local impact through SME participation and community social investment initiatives. Without further ado, I will hand over to WSP and the Eskom team.
Thank you, Ashlyn. Yeah, it was indeed a pleasure for WSP to be awarded as the Mega Projects Award for a value of more than 1 billion. My name is Dinesh Baldu. I'm the Managing Director for the Power and Energy Business at WSP in South Africa. And I'm joined by a team of panelists, Alkesh Ramprotal, a Technical Director in the WSP Power Business, Andrew Galbraith, the Director for the Power Business, Transmission and Distribution from WSP, and Mfundi Songo, the Senior Manager for Eskom Generation Renewables Projects from Eskom. So we'll take you through the best projects and some of the key moments and the highlights of the project. Start off with the project background. In terms of the project, it was part of the World Bank funding as a set criteria for the major build program. And what it required was a carbon-friendly alternative to be implemented in Eskom as an alternative to the Kiwano CSP project. The targeted daily discharge for the BESS project was 1,440 megawatt hours into the network. And this sizing was derived from what the Kiwano project was meant to provide. In terms of the project, in terms of the Eskom phase one project, the phase one project comprised 4 packages. Package 1 was the Skaapvlei 80 megawatt, 320 megawatt hour project. That's close to the Sere wind farm. Package 2, Lot B, was Pongola, a 40 megawatt, 160 megawatt hour project. In Pongola and Ilanskop, a 8 megawatt, 32 megawatt hour projects in Ilanskop, just outside Pietermaritzburg. Package 3, where they comprised 2 lots. The one was Kraftwater, 5 megawatts, 30 megawatt hours, and Palaciable, a 9.5 megawatt, 45 megawatt hours. Lot B was a HEX site just in Worcester, a 20 megawatt hour, 100 megawatt hour site. This was the first site to be commissioned and come into operation. And then package 4 comprised 2 lots, which is Malcote, 35 megawatt, 140 megawatt hours just outside Jeffreys Bay, and the Rietfontein project, which is a 2.04 megawatt, 6 megawatt hour site in Rietfontein. The key projects that we will cover here would be Lot B, Pongola, Ilanskop, and from package 2 and package 3, Lot B, which is the HEX site in Worcester. These were the sites that we've managed to complete during our time on the project, and that will be more or less the focus of this presentation. In terms of the project objectives, the key objective of the project was to address a few of the network constraints, and that included network strengthening requirements for capacity, the provision of ancillary services, and energy support services. And just around these objectives, the BESS sites were selected to support the local network constraints and to provide services to the system operator. In addition, we're looking at supporting the integration of renewable energy resources into the network, and that's by making some capacity available, specifically around the Sere area. All of the studies were completed by Eskom prior to our engagement, and it indicated that a minimum requirement of 4 hours capacity per site will be procured. At this point, I'll hand over to Mfundi Songo, who will speak through the sites as well as the other applications for the BESS.
Thank you, Dinesh. My name is Mfundi Songo. As Dinesh has introduced me, I was leading this project, all the BESS sites in Eskom from the beginning right up to the end. We had a selection of sites throughout the country based on the local network needs as a first pass. And then we assessed the space availability in each of the sites that we selected. And then thirdly, we did a network analysis to ensure that whatever site is chosen, it integrates into the network and it just doesn't become a white elephant, but it serves the purpose for which it was designed. And out of that, a report came out of each of the substations that are listed here. I'll start with the far northern Cape, the northern part of the country, the Northern Cape. Rietfontein is 5 megawatt, 1.5 megawatts, 6 megawatt hours. That will save the far-flung rural electrification area where if we were to build a new line, it would have cost us close to R1 billion. Then I'll go to KwaZulu Natal on the far right, on the far right eastern portion of the presentation in KwaZulu Natal. It's 40 megawatt, 160 megawatt hours at Pongola. This site has stabilized the network. We were having a little bit of challenges in terms of additional power to develop local load. And then we go down south in Pietermaritzburg at Ilanskop is 8 megawatts, 32 megawatt hours. It is to ensure that we support the local load. if you look at the nomenclature there, in the L stands for where there is a need to supply the load shaving. The AE is for the ancillary ancillary services as well as the energy support. So the E is for energy, the L is for load, the R is for the reactive power support. If you go into the down south there at Melkot, it will be for the load shaving as well as ancillary services and energy support. And then if you go to the Western Cape, the same with Melkot, Hex, 20 megawatt hour, 28 megawatts, 100 megawatt hours, which was the first site to be commissioned in this program. And then you go up, you go to Palesievel, it's 9.5 megawatt, 45 megawatt hours. It's for both ancillary services, energy supports, and load shaving. Grafwater, it's only for energy support and load shaving. You cannot provide ancillary services because it's a very small lot, so it was considered not worthy to do that. And then you go to the flagship, Skaapvlei. Because of its size and because of its location connected to Siri Wind Farm, the ancillary services as well as energy support services will play a big role. And all these projects were identified by Eskom and then worked on, and the reports done and studies done by Eskom. Next slide. In terms of BESS provision, what will BESS change in terms other than any support, ancillary services and the like in the country? When we look ahead and look at clean energy technologies and the green revolution in terms of decarbonization, decentralization, as well as digitalization, the BESS industrial complex will ensure that, first of all, it provides services to the renewable energy source and enhances integration of renewable energy resources because they are intermittent. In addition to that, it will create the local industry on the far right-hand side. So if you look at local industry, the power quality supports, the energy management systems, the universities are currently involved to do a lot of studies so that we can understand how this beast fits into the network. And then in terms of if you look at the size of this BESS, we've got small figures such as 1.5 megawatts, 6 megawatt hours. The distribution system operator will ensure that these battery energy storage systems integrate into the network seamlessly and easily. And then if you look at the buildings, currently we've got a lot of solar plants being installed all over the country. The battery energy storage systems will ensure that the charging points and the rest of the networks are used optimally. And then in terms of the distributed energy resources, they are all over the country. Whether it's wind, solar, or mini hydros, or any other that you can think of, it has to be aggregated and ensure that it smoothly integrates into the network, and that is the best. That is the best function. In terms of the energy market, with the new market forces that are coming into the network, it is critical that there is a balance in terms of flexibility, in terms of availability, and in terms of stability. And that is what BESS will bring into the network, and it's already doing that. Thank you very much.
Thanks, Mfundi. So I'll just move on to touch on the scope that both ourselves and Eskom executed during these projects. In terms of the services, the project started off with the pre-development, which included pre-feasibility studies, the feasibility studies, and the concept designs. This phase of the project happened prior to the WSP engagement and was conducted by the Eskom project development team. So once WSP came onto the project, this phase of the project had passed, and Eskom conducted all of those works. In terms of the development, this is where WSP was quite heavily involved together with the Eskom team It was quite an integrated approach in terms of moving through these items. On the development phase, we did the spec and the specifications, technical specifications, and the tender development. We assisted on the tender management and evaluations, and then the EPC contract negotiations. And then once we moved on to the construction phase, we did project manage, contract manage. We did the design reviews together with the Eskom technical teams, and it was quite an integrated approach and had to be managed quite carefully, given that the project were all over the countries between different working groups and working areas, and also in different divisions. So that design reviews was quite a coordinated and integrated approach that was done between both ourselves and Eskom. And then on the supervision side, we did the construction management, construction supervision together with the Eskom teams, and attended factory acceptance testing for all of the kit. On the commissioning stage, that was also quite heavy involvement, and also given that it was in different parts of the country, between different operating units, there were slight nuances between the requirements, the commissioning requirements, as well as the integration requirements. So the team had done the set witnessing, functional testing, and performance testing. And then the O&M monitoring, which is the phase that Eskom is currently in on this project. The project entails a 5-year O&M contract, which is being done by the EPC contractors, and where skills transfer is being done from the contractor through to the Eskom personnel that are on the program and operating the system. Just in terms of a high-level scope of work, the scope of work included engineering services, which was the preparation of the specifications and the technical requirements, design reviews, inspections, witnessing of testings, and all other engineering services. From a procurement perspective, we did a review of the bidding docs. That's the overall bidding docs, which was prepared according to World Bank requirements and World Bank templates. As we did assistance in the bid process, including the technical evaluations and contract negotiations with the preferred bidders. On the construction management side, it was supervision of project sites through our resident engineers and clerks of works. And then the project management services entailed that we represented the employer in the execution of the project. And services also include day-to-day management of the EPCs, support on integration issues. That's basically where we're sitting on brownfield sites and integrating to the existing kit that required quite a bit of integration, and we provided support there. General supervision of the contracts, contract management, quality, health, safety, environment, risk, scheduling, control, and overall construction management. So it was really the full breadth of services that was included here. Just in terms of the team, the overall team was led by a project manager reporting into the Eskom project manager. And the key areas of the team was the project management and procurement team. And there it was the provision of legal specialists, quantity surveyors, cost controllers, quality specialists, health and safety teams, project and contract administrators, document controllers, and project planners. The technical team, from an engineering perspective, it actually included a whole breadth of multidisciplinary engineers and services, which was comprised of civil engineers, structural engineers, HVAC specialists, control and instrumentation engineers, substation engineers, BESS engineers, and commissioning specialists. That engineering team was both out of South Africa as well as the international business. And the objective there was to bring international best practice into the project, given that it was one of the first in South Africa. And then we had a resident engineer with a team of clerks of works looking after the quality on the site. I would just now hand over to Alkesh Rampratal, who will cover the technology selection and the best design.
Hi, good afternoon, everyone. Just going to take you all very quickly through the overall components on the BESS. So if you look at it in your BESS rack, it starts up with a cell. From the cell goes to module. Module will then be connected into a rack. And on the rack, you have your BMS, which will manage the modules itself. And from there, it will be connected to the PCS. So that's just a very high level sort of diagram of how the batteries are all connected together. Next one. In terms of the other components that form part of the BESS system, we have the batteries. And from the batteries, you have your PCS, which is then goes through your transformer, your RMU switchgear, and that's then reconnected to your PLC, be that 1133, 22 or 33 kV. What we also we shouldn't be forgetting also is the supplies, the auxiliary supplies for the functioning of the components. So example, if you to get your battery subsystem or your battery container crudely put, it requires an auxiliary supply to make sure that the cooling is adequate. Yeah, there are sort of approaches to cater for self-support itself from the batteries. It has its advantages and disadvantages, but typically you always would like to have a separate supply to ensure that in the event something goes wrong, that the batteries can be maintained at an appropriate temperature. Also, what's very crucial with these batteries is your thermal management within the battery racks as well as the containers. As everyone knows that once they catch on fire, they're going to burn, and you can't really put them off. So the management of the thermal side, and to ensure that as soon as there's any deviation from your set standards, that the supplies to these batteries are all cut off, and you can safely shut them down and investigate what the issues were from there. Okay, so the one thing that what sort of transpired on the Eskom project, there were two contractors appointed, or two separate EPCs. The one came with the mini, let's call it mini containers. They were very small. They were about 373 kilowatt hours per container, as opposed, if you look at the picture, the first one, that everything was self-contained, which had the cooling system, the HVAC, the cooling system, and that basically from they supplied to the PCS. In the second EPC had a slightly different approach. They had the traditional 40-foot containers. So within the 40-foot containers, they had the racks which were installed and the HVAC. So in terms of delivery was slightly different. Here, the containers were shipped empty, installed inside, and then the racks or the batteries were then manually installed on site into all the separate racks. So I think what's over here is also what you would see is that this trend has now moved away from the so-called 40-foot containers where they ship them separately, I think from a costing as well as a practical arrangement. And then similarly, they had a container for the RMUs, the PCSs, as well as the inverter transformers. So I think what the intent of this one is just to show that when we started this project, it was a few years ago. And the Eskom HEX, like I indicated, the capacity of the one of the vendors, it was 373 kilowatt hours in a so-called mini module of 1 meter by 1 meter by 2.4 meters. That was the first so-called mini container. Then the transition went to sort of 5 megawatt hours in a 40-foot container. And currently we're sitting on sort of 5 to 7 megawatt hours in a 20-foot container. So I think what you can see from here is the energy density of the cells has improved substantially. And, I think the high the energy density, the high the capacity, but also brings in other challenges as well. I think in terms of the cooling and temperature management, it becomes a lot more crucial. And the monitoring system that goes with it is also as important. One of the other big drivers that we're seeing, but it's been inspired more by the EV market, is the C rating or your charge and discharge rating for the cells. If you look at your stationary so-called solutions, they typically 0.25 C, going up to 1 to 1.5 C. In terms on the EV, now because they're trying to shorten The charge time, I mean, we're going up to 7 to 10 C batteries, which actually brings in different opportunities in the ancillary service market, going forward. Because typically when there's a disturbance, you want to either charge or discharge very quickly. And that's where these batteries have a benefit to the network. The actual technology itself, when the initial ones were done, they were typically the NMC cells, which then moved to the LFP. The current generation is still LFP, but I think shortly we're going to be seeing the sodium ion. They have now been installed in the EVs. There's been also a few small stationary installations as well. So that's the main reason is the operating range, the temperature is much better, performance is better, and not to forget the chemistry also is fairly safe compared to the LFP as well. So in terms of the inverters and PCSs, when you looked at the first the solutions that were traditionally installed, they were central inverters. So you've got one inverter connected to potentially 5 or 6 different rows of batteries. If you look at going forward, these have now moved to string inverters, smaller inverters to give you the flexibility and also improves the reliability and performance. So that's where we see these PCSs going. And also from a installation perspective and execution, they've stuck with the 40-foot containers. Within the 40-foot containers, they have the PCS transformers and the RMUs. So from a deployment, you literally create your platform for your battery, you bring it down, put your PCS or your PCS/RMU containers next to it, and you can connect up. So your deployment time is much quicker. The other important thing to note now, the inverters or PCSs, they're traditional inverters with generally your grid following. However, with the penetration of renewables and also with the unpredictability of renewables, there's a bigger drive to start going into grid forming inverters. So I think one of the main reasoning here is that it gives you more flexibility in terms of the network and controllability. I think the one challenge with renewables is that your support for the network is very, very weak and very unpredictable. So the quality of supply is managed by that, as well as in the event that you can also go from, this is still pretty newish where they're trying to use it for black start capability as well. So those are some of the advantages of going into grid forming inverters as well. So the challenges with grid forming at the moment, it is evolving. There are limited standards that's in place, and also the testing and certification. What we've seen is internationally, there are a few countries that have updated their grid codes to include it, but there's still a bit of the gray area in terms of how to manage it and test them as well, and the certification of the inverters. The last part that's quite crucial, and it's it goes up with your upfront planning, is the augmentation strategy. So when it comes to cells, the previous generation, it was very difficult. You were not allowed to mix, you cannot mix old and new cells. Therefore, when you plan how you're going to augment, it was very crucial. So the picture that I have up here is from one of the suppliers that had, that was their proposal for augmentation. And if you look at it carefully, you'll find that it has, to include new cells or new batteries meant you had to relocate some of the older ones. And just the practical scenario means you have to take the plant down, move the batteries to the new platform, and then bring in the new ones, which is quite disruptive and not ideal. So what's essential when you are planning, you make sure you plan for these things up front. However, with the modular version of batteries and well as the smart transformer stations. These have now sort of simplified the augmentation. So before you would have to ensure that you had, well, I either would have had created your cables and areas for it. Going forward, all you need to do is just ensure there's adequate space, do all the main civil works, so that when you need to increase your capacity, it'll be just doing the basics and installing the new containers for the BESS or the RMUs, the STSs. And what's good about the new ones is your downtime is minimal because you can literally do everything, and then even connecting up to linking up the two STSs becomes quite simple just by connecting the cable or terminating the cable between the RMUs. So from a capacity extension, it is quite flexible now. And we spoke about the prep of site. I think it's important to try and do it upfront. So when the time comes to augment your disruption, and you also don't want to bring in too many heavy equipment to work on site. So therefore, if you can do all that upfront, it also helps as well. Thank you.
Thanks, Lokesh. So now Andrew Galbraith will take us through not so much the project progress, is just in terms of where the projects are at the moment and a few key points on each of the projects. Andrew?
Thanks, Dinesh. So I'll start with the first project, which was part of package 2B, that was Elands Corp. It was an 8 megawatt max, 32 megawatt hour BESS. As you can see from the pictures, the site was pretty constrained. So we had to do some modifications to the 3-tier fence requirements that Eskom initially put in place in terms of their risk assessments. So that was one of the novel parts of the design. As you can see, it's an open boat design, as Alkesh explained earlier. The latter technology nowadays is obviously going for the containerized, but this was open boat with central inverters. Another part of this was that we had to install a new telecoms tower, 45 meters in height in the area due to the comms issues that Eskom was experiencing. And from management side of things, we had 2 municipalities we had to deal with in terms of biodiversity management plans, drainage and building approvals, etc. So that proved to be quite challenging. And then also the stakeholder management that was done between Eskom and the contractor. That proved successful, and we were able to implement the project. The project was designed for 20 years, and due to the constrained site, there was no augmentation on the site. So we've oversized the project to provide that power nameplate rating for the full 20 years. And that is about it on Elands Corp. Dinesh, if you can go to the next one. So this is the second part of package 2B. This was in Pongola, in northern KZN. Again, the site was already on Eskom land, and it was designed for 40 megawatt hours. 40 megawatts, 160 megawatt hours. The site itself was also constrained due to issues with land ownership and also biodiversity areas. So as you can see, just coming into the site, there's actually a baobab tree. We had to make space for that. That could not be removed. So that was protected during the duration of the project installation. And as a consequence of this and the constrained site, we had to have off-site laydown area, which was 10 kilometers away. And this was also just down to the fact that we had environmental boundaries we had to fall within. And we also had neighboring land that was utilized by the farmers, so we couldn't encroach. We did some extensions on the existing substation, but that was fairly minor, replaced a transformer. And just some highlights, there was a critical biodiversity area on the site where we had to basically remove bulbs and replant them in another area off-site. Also, Pongola being an area where there are a lot of snakes, we had a professional snake handler on site for the duration of the project, and he was kept busy from time to time. Thanks, Dinesh. Next slide. Okay, the final one was part of package 3B. This was a separate contractor down in the Western Cape, near Worcester. The site's called Hex. It was a 20 megawatt, 100 megawatt hour battery. As you can see, it's the autonomy is 5 hours as opposed to 4 on the other two sites. And one of the reasons for this was that Eskom is trying to support the farmers in the area for their power and irrigation requirements, which is generally happening in the evening. So, as we understand it, for the other two sites, for energy support, the batteries are dispatched during morning peak and evening peak, whereas for this site, it is generally it could be dispatched as one single dispatch for 5 hours. The other part of this project was that we were linking to a substation with constrained space as well as constrained power requirements. So there was a mobile transformer station that was put in. It was an old Eskom transformer mobile unit that had to be refurbished and was utilized for the duration of the project. We also had to install oil dams as the transformers were upsized from 10 MVA to 20, and they required new oil dams to be installed in the substation. As far as just a point on economic development, at the peak of the construction activities, we had 250 locals employed, and we had 10 SMME partners. So that is just, in a nutshell, the 3 projects that I want to talk about today, and all of them have now been in operational acceptance. The first 2 being the end of 2023, and this one just later, a couple of months later. Okay, Dinesh, you want to move to the next slide, please? So in terms of teamwork, the integrated team, the WSP and Eskom team worked hand in hand to ensure a successful delivery of the project. And as described by Eskom, just a couple of quotes from Eskom. Eskom team, that's group capital and distribution, and the WSP team are currently functioning at the performing stage of Tuckman stages of group development. The WSP team has integrated well with the Eskom team and has formed a relationship that is producing results. And another quote, the WSP and Eskom team have developed an efficient working relationship with the appointed contractors and are able to resolve matters harmoniously. Thank you. And just a final slide on sustainability. The project actively promoted the inclusion of small, medium, and micro enterprises, contributing to local economic development. I gave you an example for the Hex site. We also use localized skill development and resource optimization. The contractors were required to provide construction training such as bricklaying, cable jointing, and cable pulling, machine operation, painting, welding, and supervision to local people from the towns near the site. We saw this very evident at Pongola. The corporate social investment contributions such as school support and community improvements were integrated into the contractor scope. Again, Pongola schools were refurbished from painting, and classrooms were repainted, and I believe a computer center was also installed at one of the schools. As part of the construction contract, contractors are also required to provide 5 years of O&M operation maintenance of the facilities. And during this time, they will be training up and transferring knowledge of the facilities to the local Eskom experts. And that is now in place. It's been in place for about over a year, and I believe operating quite successfully. Then during the project, a project steering committee was also set up at each of the sites with regular meetings being held to discuss the project and community participation. Community liaison officers were also employed on each site, and they were really, they showed their value in the project, dealing and helping with the local community. Over 300 Eskom personnel were trained in the BESS technology through WSP's online training, and 20 personnel in classroom programs, ensuring long-term sustainability in system operations for Eskom. And the certain equipment was mandated to be procured within South Africa, supporting local industry participation via the DTI and aligning with national localization policy. So examples, transformers, switchgear, cables being procured from the local industry and supporting that. Thank you, Dinesh.
Thanks, Andrew. I think that's it for our presentation. Ashlyn, over to you. Thanks.
Thanks, Dinesh. Thank you for that insightful presentation. We're now going to move on to our Q&A session. And we have our first question that I'm going to put up. Can you please share any lessons learned throughout the projects from your involvement in terms of development, construction, and O&M?
Thanks, Ashton. Thanks for the question. I think I'll come through and the team can fill in. Just in terms of the some of the lessons learned from the project, the key areas was on the RFP development. I think one of the things is in terms of having the project specified at the right degree or the right level, and to reduce any ambiguity. Those were some areas where changes were introduced, and I think there could have been some improvements there. I think on the evaluation phase of the project, on the technical evaluation and looking at the bidders' proposals, I think if we should have had a bit more time on that. That is quite a detailed process, and just looking at the whole thing holistically on the BESS project, we did require more time for that, and we had to push to get through the evaluation, which was a bit of a challenging process. I mean, trying to stick to dates and answering clarifications without moving things out, that was a bit challenging. So I think that's one of the other aspects. From an technical perspective on the environmental side, I think it's quite key to have your environmental authorizations and the like in place prior to procuring, or even getting onto or prior to procuring and prior to the detailed design phase. We did have a few challenges in this area, and it had resulted in a few delays on the project. I think the team managed that well, and overall we were able to mitigate some of the delays, but there were delays nonetheless, resulting from environmental issues needing to be sorted out, just prior to the design phase and going into construction. The difficult thing with the environmental authorizations and the finalization of that was that, because it was open market tender, and the team, until the EPC is appointed, you don't know what's the technology that's going to be used, what's the final footprint going to be like, and those are key details that are required to finalize the authorization. So I think that's a key point, and something that I think needs to be sort of expedited, and to make sure it's in place prior. Some of the other lessons learned is through the sort of commissioning phase. I think commissioning planning and that sort of management needs to be sort of contemplated and not really contemplated, or planned in detail some months before that, because the thing with these BESS projects is that they're quite short timeline projects, and you're done with the design phase and the clearing, and the construction is pretty quick. So the thing is not to be caught with the commissioning without having planned in detail in terms of all of the commissioning requirements and whatever is required. And especially in this case, given that we were working with different operating units, both WSP and the EPC and Eskom themselves, is just in terms of getting the requirements down for each of the OUs, being a first of its kind and the first sort of technologies that we were putting on. So those are some of the ones that I get out of the just on the top of my mind. Alkesh, Mfundi, Andrew, happy for you guys to come in.
Okay, so maybe I can just add what's important, and Dinesh did highlight it previously, was the integration between the customer, or should I say the plant owner, and the EPC contractor or the supplier. If you can get that right, it does help with expediting any so-called decisions and ensuring that the delivery also meets the expectation of the client, rather than where they would just do the design, go away, and then send it through to the client. If the client is involved from the start, it helps significantly in reducing any possible changes as you start to construct as well. Thank you.
In addition to what has been highlighted, one of the key things is the review of the documents by Eskom, the final design package, the turnaround time. In this case, we had to change the manner in which we worked so that as soon as work has been done and there are some changes, they had to come to the design review technical team steering committee. And the other lessons that we've learned from this is the quality of work on the site. Because it's a new product, it's a new way of doing work. In terms of the finishing qualities, such as the earthworks, the earthings, as well as the drainage pipes, all those items, they need further refinement based on what we have currently. And also in terms of how the current substations are designed to absorb and integrate BESS, because it's a new technology, it's almost a separate new substation that you have to establish. So that actually brings another design element into the room for Eskom as well as other utilities. And then the other aspect is the understanding of the use of the technology and how it will integrate, as Alkesh was explaining, in terms of the grid forming and grid following inverters. A lot of money has been spent on this technology. Therefore, going ahead, it is critical that before any technology comes in terms of its other possible future aspects, we must be proactive as engineers and ensure that all grid connection and grid code compliance issues, as well as technology advancements, we almost augment or have a buffer zone where we can actually absorb such changes going ahead. And then the other item that we have to accelerate, it is the localization. For example, on transformers, yes, some of them were acquired, but we had to get them from Korea, which was a bit of a challenge because of time scale of time limit. So we must improve on that, and that is part of the learnings. And then the other element is the local industries. We find a lot of them wanting. Therefore, going ahead, we must go through the TVETs and the like to train people and ensure that we've got a pipelining of that, and that we've started in terms of other technologies that are coming into play. Thank you very much.
Thanks, Ashton. I think, if there's anything more specific on that, can be asked, but done on that one.
No problem. Thank you, Dinesh and team. Our next question, participant says, I do understand that logistically it's easy to have the BESS close to the substation. It also saves cost and probably averts land acquisition issues as well if the land belongs to Eskom. Has the optimal distance and risk issues been thoroughly studied to avoid cascade damage due to major incident, for example, fire, from either the sub or the BESS? Gentlemen, I think you guys are still muted.
I need to go.
Okay, sorry, apologies for that. So in terms of the fire design, or when you're laying out your containers, that's where you have to look at the distances between the containers to ensure that your fire, in the event that it does not go through and impact the rest of the components. In terms of the substation distance to the BESS, if you can cater it, manage the distance between the containers, it would be great to leave adequate spacing between the two. So if there's a fire within the BESS yard, it doesn't influence it. So you would find that the Eskom approach, there is, I think the closest was Ilanskop, which is approximately, I think 15 to 20 meters away, separation between the two. So that was something that was done intentionally as well, just to make sure that in the event, if there's a fire, that it would not propagate and disrupt the substation itself. Hopefully that answers the question.
Thank you, Alkesh.
If I can add more onto what Alkesh has said, in the other aspect, as part of the learnings on the specification, in terms of the designs at the substations, the firewall, in terms of the materials, where it is supposed to be, and in addition to the distance, there has to be a physical barrier that separates the battery racks, and then there must be a removable material or barrier that that is fire resistant, that can have at least in the latest spec, which is out in the public for Komati, we specified a 2 meter, a 2 hour barrier that will ensure that for 2 hours fire can burn without actually spreading between the battery modules. And then the other aspect is in terms of the containers themselves. There has to be more research. We have assigned engineers together with the OEMs going ahead, and we're already doing a study on that to say, okay, what type of materials, how do these BESS containers, how do the batteries react when there is an explosion, and then secondly, the ionization of the air within the area where BESS is located. For example, there could be a line that is next to where BESS is. So it's almost a weather station that is to check all that and ensure that we have detailed studies that previously were not done. So that's an area of improvement. Thank you.
Thank you, Mfundi. Okay, moving on to our next question. If the EPC was an international company that did not work with Eskom before, how did you manage the local compliance of that company to be able to register on the Eskom database? And what was the actual timeline for this activity?
Thanks, Ashton. I'll take that one. Yeah, so this one really varies, and it depends on the preparedness of the EPC for the projects and their awareness to Eskom requirements, as well as the requirements for local business and legislation in South Africa. So I mean, the best answer I can give there, it varies. There were various EPCs on this project, and for some of them, those EPCs, it was seamless without us even knowing. For some, it took a longer timeline. It just comes down to their awareness, knowledge of doing business in South Africa, whether they have a registered company in South Africa now or not. So yeah, it would be difficult to give a sort of standard timeline for that. Thanks.
Okay, noted, Dinesh. Our next question is, in terms of mentoring, how were the development and participation of young professionals supported and integrated throughout the project?
Okay, so I'll start with this one. Just in terms of the development program, what we as WSP did from our side is we involved graduates on the program. So those were graduates brought on specifically to work alongside us and train and develop on the program. So that was done from WSP's perspective, and that was the intent. And what was actually done was to have them through the whole life cycle of the scope, to expose them to different areas. There was also a training aspect to the Eskom team. From an Eskom side, also there were quite a few team members who were seconded to the project, and there was a fair amount of on-the-job training that was done and skills imparted through the various portions of the project, and more specifically on the sort of site engineering, site monitoring, and the commissioning side. That's where there was a fair amount of skills transfer done there. And then from the EPC side, there were various local development and CSI initiatives from schools, and providing I think computer equipment and the like. That was to uplift the community. And then also under the program, there was quite a fair amount of training, from getting semi-skilled workers up to skill level, when it came to bricklaying, construction, and the like. So most of those skills were brought in from the local communities, and there was an intentional drive to get those people upskilled, and also just in terms of upskilling them, it was ensured that both the EPC as well as everybody else working on the project had the right personnel and expertise on the site to actually impart the knowledge to them. So I think the training and development was very intentional from all parties. I don't know if anyone else on the team wants to add.
Yes, from Eskom side, we had a lot of training, both in terms of the modeling, the designs, and the specifications, which we had never done before. So we developed and we set up a number of people that were strictly focusing on BESS, how it integrates into the network in its entirety, from the design, the planning, the studies, the modeling, the testing, and the like. And that they were involved through and through right up to the commissioning. And that has assisted us a lot in terms of preparing for the future renewables integration in mass, rather than this as just an introduction. So this was an introduction. So we've set up, and in the power stations too, we've assigned people that are being trained to understand how this technology works and integrates into the network. Thank you.
Thank you, gentlemen. Moving on to our next question. Any difficulty experienced in integrating new technology / hardware to old existing hardware, and was there any need for unforeseen infrastructure upgrade before work scope could commence?
Yeah. So I'll take that one. So in terms of the assessment, what was done right up front was to look at the equipment that's at the existing substations. So in terms of unforeseen, I wouldn't say they were anything major, but as part of the assessment up front, well, that's when it was determined what components of the existing plant needed to be upgraded. So we had a situation where the transformers had to be upgraded, as well as the protection schemes as well. So it's quite essential to ensure that the assessment up front is carried out properly, so you don't have surprises when you get onto site. Thank you.
Thank you, Alkesh. Okay, our next question was, what emerging technologies, engineering capabilities, or skills does WSP believe will be crucial for the next generation of BESS projects? And how is the company preparing engineers to lead this rapidly evolving field?
Okay, I'll take that one. So, like you said, the whole technology is evolving very quickly. The only way for anyone to keep track is to be in touch with OEMs and suppliers and see what the market is doing. And part of our internal program is to we have junior engineers that we are also sort of get them involved in with the technologies, and also to try and get them to understand how it is, and also from a modeling perspective, how they are, well, what needs to be done. So it's a combination of doing sort of keeping in touch with the suppliers, doing sort of research by yourself, as well as also look at the installations that are currently going on and basically learn from them. So from a WSP perspective, well, as I indicated, we have juniors that we are basically trying to skill, and we sort of have informal and sort of formal sort of programs to actually do that as well.
Ashton, just to come in and add, just in terms of being future ready, and BESS is one of the technologies and all other technologies. So WSP internally, we have our training programs where which is constantly updated. Keeping in touch with whatever is the latest in the market, where technologies are going. As WSP as well, we have a lot of leaders in the various sectors and on various technologies who provide a lot of internal training and sessions available company-wide. That's across the breadth of engineering, where the latest trends are discussed, where technology is going, what's the anticipation, and there's a lot of thought leadership pieces that are prepared and shared within the company, as well as presentations done externally on technology developments, where we see things going, how things are going, and what's expected in the markets. So there's a lot of studies and thought leadership pieces there, and open training. And one of the advantages that WSP got, being a company that's 83,000 strong and in over 50 countries around the world, is that we are able to bring the best of the expertise from various parts of the globe, both to impart knowledge to our teams wherever, and also bring that international experience into projects. So all the designs and however we conduct projects, or way of working, knowledge on technologies, etc. It's the best of what's to offer internationally, that we try and keep to that standard throughout the world. So it's really a wide breadth of services. And just from a training perspective, something closer to home, in terms of developing engineers, both young engineers and engineers throughout their career, WSP strongly supports growth, development, training programs. I think something that's big for us is getting our engineers up to your professional engineering status, project managers, with the relevant project management qualifications, and supporting them through their growth, through those programs. So it's quite a close eye that we pay to professional registrations and developing our people and exposing them to the right type of work to help elevate their careers. Thanks.
Thank you, Dinesh. I think coming off of that response, the next question was, what engineering innovations or design principles has WSP applied in the BESS projects to maximize performance, reliability, and grid stability? And how do these solutions set new benchmarks for engineering excellence?
I'm just trying to think. Maybe I can come back to that one. Just checking with the design engineers. Yeah.
No problem. Okay, our next question. One participant would like to query regarding the decommissioning plan of the projects.
Yeah. Only on the decommissioning side, are you there were decommissioning reports, and so just in terms of the decommissioning, what was looked at and discussed during the phase of the project, during the build, was prior to that coming on, it was studied what would be the decommissioning cost in terms of life cycle, what will be the environmental requirements, basically what's the chemical composition of the various components making up the BESS and other parts, and how they will be handled in an environmentally friendly manner. So just in terms of that was all entailed in a full decommissioning report. I don't have the full detail. I was on an oversight level, but that was one of the key aspects of the front end of the project. I'm not too sure if there's anything, Fundi, from your side or Alkesh, to add.
Yeah, in terms of on the decommissioning side, because it's new technology, each EPC had to bring in their proposal, and we've received several proposals which are aligned with our national environmental laws and disposal. For example, one of them says that the containers will be recycled and taken back by the original equipment manufacturers and be fitted with more energy intensive batteries, or they can be used like a 20-foot container. They can be repurposed and be used for other purposes, but what is recyclable and usable can be collected. So it's a new business area that we can say should be coming in. It's a completely new business area that has to be looked at from a reclamation of what has been used and future usage. Thank you.
And maybe just to add on to that, what we are seeing is quite a few of the battery OEMs actually have the flexibility now to take back the batteries when they expired or when they're not in use anymore. So what we've seen is the OEMs have their own recycling plants and facilities to take back the batteries, and they are starting to give or the client the options to say at the end of 20 years or 15 years to actually take back the batteries. In terms of the that can be as part of the agreement, and also I think it helps in terms of planning as well as the decommissioning, also in terms of the cost as well. That's something that's still pretty new at the moment, but that's what we're starting to see. I think the main reason for the OEM to take it back is that from the recycled material, they're actually starting to produce the new cells from there. Thank you.
Thank you, gentlemen. Our next question is, where is Eskom going with their future BESS programs, and how strategically positioned are the future sites of these BESS programs?
In terms of the future of the BESS program in Eskom already has phase 2 of these current BESS projects, which will add and which will put an additional 140 megawatts, 160 megawatts, sorry, because this phase added 200 megawatts, and the total was supposed to be 360 megawatts, which we'll call phase 2, which will involve other substations such as Kupram, Witzenberg in the Western Cape, but that is a smaller amount, that 140 something megawatts. Now the big ones that are already in the public domain in generation, Komati is currently in the market. It's 150 megawatts, 600 megawatt hours. And that is only in one site. And then looking at other sites all over the country, we're looking at figures such as 200 megawatts, 300 megawatts. So if it's 200, it's 800 megawatt hours. 300, you're looking at something like 3 times 4, 1,200 megawatt hours. Those are big figures that are coming. And in some instances, there are figures such as 500 megawatts. But then all these are designed in such a manner that they will be closer to where there are renewable resources such as solar and wind, specifically solar, and that they are expected in most cases to be grid forming inverters, because we are fast losing the base load in Mpumalanga, and as we phase out coal-fired power stations going ahead, it is critical that we have a stable and a flexible grid, though with artificial electrical inertia. That is what we're studying to ensure that these figures that we're talking about, they don't just come, but they come with a benefit into the network. And the 150 megawatts, in terms of the time series, the 150 megawatt Komati BESS construction should start anytime before the second half of this year. That's 150 megawatts, 600 megawatt hours, based on the lessons that we learned from the others. So this is a big one. Thank you.
Thank you, Mfundi. I think we answered a lot of questions. We just have one final question. What is the most exciting aspect of engineering a BESS project, and what would you say is the most challenging?
The most exciting aspect of working on a BESS project is the fact that you have this unknown element, and you are more like a fortune teller. And when you tell people this is what it's going to do, and you have to convince them, and you have to write reports, and you have to write specifications, that's the excitement. And then you have to visit the technology, the OEMs, or talk to them, and they bring different aspects. And then you look at, you assess, and you check which one really talks to what I expect. And then the most difficult part comes when now you have to talk about implementation. That is the scary part, because whatever has been written on paper that it will be done in this way, we have got a lot of experience in terms of that. So what is being proposed and what is done is there's usually a huge difference, and you can expect disappointments in some instances. But then at the same time, there's another exciting element where you get some EPC contractors that have done that just do the excellent job and they exceed your expectations. So it's a tense moment. It's a moment of suspense. But the most exciting part of it all is the team that one works with, having environmentalists, having land acquisition people, having civil engineers, having chemical engineers, and above all that, working with communities and having people that have got that are directly affected on the ground. So the people who are the oxygen of the work, that is where the excitement, the overall excitement comes. And then finally, when the product is delivered and we are told now it's being commissioned, it caps it all. And that's what makes me happy and the team. And then everyone celebrates. And then we now forget about all the squabbles that we could have had, because it's really a tense moment where even the people like the WSP, as our partners, we have a lot of very passionate discussions, and they also do the same together with their designers. But the good part of it is that WSP have managed this very well together with us. We've managed this very well in celebrating today, where we've gone over challenges. So it's been a complete set. Thank you.
Thank you, Mfundi. Dinesh, I'm not sure if you want to add in from WSP's side.
Yeah, thanks, Ashton. I think Mfundi echoed most of it. Certainly, I think the people aspect was one of the biggest, most exciting things, and that varied from skills development, empowering the local communities, empowering ourselves, even people within the organization and South Africa, bringing international experience in, working together with Eskom as part of an integrated team. I mean, like Mfundi says, there were good technical discussions, there were good robust discussions, but you make a lot of friends along the way, and I think that was one of the big things. And I think something else that was very fulfilling is just the scale of the project, and it being one of the first in Africa, and bringing this new technology. That was really exciting. We did encounter a lot of challenges along the way, as with anything new. But I think again, back to the people as a team, get together, discuss the technical. It was not only technical issues, but it was technical, social. With this multidisciplinary types of projects, you get a lot of other issues, and it was really the people working together, discussing the issues, looking at the alternatives, looking at what's best for the project, and making the decisions and moving things forward. I think that was the most exciting things for me, and I'm sure most of the team as well. Thanks, Ashley.
Thanks, Dinesh. And thank you to all our panelists for taking the time to share your insight and expertise with us today. Your contributions have enriched this Engineering Day webinar and provided valuable perspectives to everyone in attendance. We'd also like to extend our appreciation to CESA and sponsors for affording us the opportunity to host these informative and engaging webinars. To everyone who joined in today, thank you for your participation and continued commitment to advancing engineering excellence. Have a wonderful day forward.